Okay, one of the things that's really great about digital audio or digital sound design is that once we get sound into the digital domain, we have a lot of different options of things that we can do with sound that we have a difficult time maybe doing with acoustic settings. One of the issues around how scales have emerged throughout most cultures is one of the problems that mathematicians and acousticians and composers and theorists have dealt with for many years, which is really trying to understand what kind of tuning system, or what's also called the temperament system, that is used to create scales in various cultures. So when we look at the history of Western music, we can go back to the classical Greek civilizations, and where there was much of the research that we know about acoustics was taking place with Pythagoras and Ptolemy. A number of important researchers were trying to understand how does the overtone series work, what kind of tuning system emerges from those pitches, what is the most logical way to approach creating scales for melodies and harmonies. Harmonies weren't really used at that point. But we can also go around to other cultures. China had really a lot of great research for many years throughout the history of that country. India as well came up with its own system of tuning system. When you take a look at, say, Indonesia, for example, in Java and Bali, they have their own scale systems, which are somewhat specific to their approach, based upon a 5-note scale, which is called Slindro, and a 7-note scale called Pelog. Has a very different kind of relationship of tuning to those. So as you go around the world, you find throughout history that this, the concept of how we create the intervals that are used in particular scales is a very complex system, and it's very culturally specific. So if we take a look at the history of Western tuning and temperament, we find an evolution of a lot of different systems have been in place, and there's been a lot of mathematics that have really helped develop kind of the evolution of that system. So today, if we look at what most Western music uses today as far as the tuning system, it's a system called equal temperament. Equal temperament is one that most of the music that we hear in the popular genres and for the most part in many classical genres will also be equal temperament. When you are tuning a grand piano, acoustic piano today, usually that is tuned to a specific equal temperament design, so that allows you, the pianist, to play in any particular key. So equal temperament is an evolution of a number of systems that have sort of codified into perhaps the late 19th century, early 20th century is when this became standardized. So today, that is the most common system, but there are a lot of musics which still try to utilize different other kind of historical tuning systems, and many composers and many theorists are experimenting with new kind of scales that are based upon new mathematical models and have a whole different kind of basis for how you create scales. So what I want to do is take you through just quickly the introduction to sort of what are the main tuning systems, and as you start to think about sound design, perhaps if you're interested, you can explore this more in depth and really discover some of the more subtle nuances that the tuning system will give you. And then also will help you understand when you are doing sound design, say for classical Indian music or for Javanese music or other kind of cultures, you'll understand that there is something important about maintaining these tuning systems in order to capture some of the aesthetics of that music. So what I'm going to do for you today is take you through a few web pages that have quite a bit of resources on tuning and temperament, and maybe refer you to some other ones that you can look at on your own, and talk about the 4 principal tuning systems that have been used in Western music throughout our musical history, and then hopefully give you some understanding for how tuning works and what are the issues around that, and then we can talk about how that can be used in compositions and what that does for composition. So the first page I want to take a look at is this one I have open now, which is the mathematics of tuning and temperament. It also has some audio examples. When I do this introduction, I will play for you an audio file of, there's a Kurzweil sampler that I have in my studio, which has the ability to change from equal temperament to just intonation, which is one of the 2 systems. And we can hear the difference between those 2. I think you'll be able to be quite shocked at sort of what happens when you change tuning systems and what that does for the system of consonance and dissonance in our understanding. So if we kind of quickly go through this website here, you can sort of see some general overview. The Western music, as I mentioned before, is where most of this is occurring. The Western music, we tend to work with a 7-note scale. The 7-note scale with an octave is a 2-to-1 ratio, as we've learned in the overtone series, is the sort of standard for most Western music, and that goes all the way back to the Greek civilization. This idea of the octave and the overtone series, where those pitches emerge, is an important originating philosophy once Pythagoras discovered that. So we see the 2-to-1 ratio is a very important idea, which gives us the notion of the octave, which is somewhat standard throughout most cultures. They do have this notion of the importance of the octave and that tuning system. Interestingly enough, in Java and Bali, we do have something more called a stretched octave, where they don't tune in pure octaves. They will find the octave and then make the octave a little bit sharper, and that's more of a preferable aesthetic. So the octave is mostly universal, but not completely. So what are the intervals that we're going to be looking at? If we take a look at going back to the overtone series, we can see that the overtone series, refreshing us, our memory on that again. I've started an overtone series on the low C. This could start on any particular pitch in the scale, but just for convenience sake, we'll just start on the low C. The intervallic relationships of the overtone series are always the same. So we have the 2-to-1 ratio gives us the octave, as we can see. The 3-to-1 ratio gives us the octave plus the fifth. If we talk about the relationship between the third and the second partial, that's a 3-to-2 ratio, which is another way of talking about what we call a perfect fifth. So a perfect fifth is the name for, mathematically, a 3-to-2 ratio is what that distance is. Then going up the series, the next note is another octave, the C above that G, which is the fourth partial. But then if we look at the relationship of a G of the third partial to the fourth partial, that is a 4-to-3 ratio, but it also is referred to as a perfect fourth interval. And so we talk about the distance of intervals in these terms of fourths and fifths and thirds, so forth. But if we look at it acoustically, it's more accurate to refer to it as a specific ratio, because that ratio determines then the size of that interval. Because as we'll discover, these different tuning systems, there aren't consistencies as to, once we get to the smaller intervals, such as seconds, there are many different varieties of seconds and semitones, half steps that we can have, and that becomes part of the problem in trying to identify which tuning system we want to use. So the 4-to-3 is the perfect fourth. Going on up, the fifth partial is the E in this case, which gives us then between the fourth and fifth, we have a 5-4 ratio, which is the natural, if we were to say, the natural major third. So C to E we refer to as a major third. And then obviously moving up, the next interval is the 6-to-5 ratio, which is the minor third. Now you'll see on the overtone series that I've got B flat written here, but I've got a parentheses around the B flat because it's not really that close to a B flat. It's in between an A and a B flat is the next interval. Because remember, these ratios are getting smaller as we move up the series. So we have a minor third, which is a 6-5 ratio, and then we have something that is a 7-6 ratio, which is in between a minor third and a major second, and the same thing on the 8-7 ratio. So that's why that B flat, that seventh partial, is often avoided in instrument. When you have a trumpet or something that plays the overtone series, usually they will try to avoid the seventh partial because it does not fit into the tuning system very easily that most people adopt. But what gets interesting is looking on up the next overtone series, where we have the C to D, which is the 8th and 9th partials. So we think about C to D is, in modern terminologies, that is a major second interval. But look at the ratio, it's a 9-to-8 ratio. And then look at the next two notes in the series. We have a D to an E, which we also say is a major second, but it's also a 10-to-9 ratio, which is by default a little bit smaller than the 9-8 ratio. And so that issue has been a difficult thing for many composers to resolve, which is you have two different size major seconds. You have the large major second and then a smaller major second, but they're both major seconds, but slightly different ratios. And then as we move up, we see going all the way up to the next octave before we get the 16th partial. Then the 15th partial is the B natural. So B to C is the most standard half-step relationship that we would find in the overtone series. And that 16 to 15 ratio is one of the more standard half steps that we would find trying to lead into the tonic, as such, of the C. So we'll find different kind of half steps that will be discovered in these relationships, and we also find different kind of seconds. And then we also try to maintain the purity of the 3-2 perfect fifth, the 4-3 perfect fourth, and then also the 5-4 third. So those are the issues. So when we look at the mathematical basis for this system, we have to understand that the perfect fifth, the fourth, and then the major sixth, the major thirds, the minor third, minor sixth, those are the primary intervals that we're working with in trying to figure out a scale system.
The preceding program is copyrighted by Emory University.